Uh, this question is about comparing different ratios. You've got 2 kilograms for $12.50, 100 grams for 90 cents, 1.2 kilograms for $6, or 500 grams for $4.40. The first thing you need to do is get them all in the same unit. So change the 2 kilograms to grams, change the 1.2 kilograms to grams, and then you can start looking at this question a bit better. So that's what I've done here. 2,000 grams equals $12.50, 100 grams equals 90 cents, 1,200 equals 6, and 500 grams equals $4.50. So now we can just start looking at it, and I'll do this question in two ways. So 500 grams, if we want to compare this to the 2,000, well, you're going to need four of these. Two to make a kilogram and another two to make 2 kilograms. So four times this, so 500 grams to that is four boxes, and four times 440 is $16 something. So, well, even more than $16, $17.60. So it's not going to be 500. If we compare the 100 grams to 2,000 grams, well, what's that? If we times it by 10 boxes over here, so 10 boxes would be 10 times the 90 cents, which is $9. So 2 kilograms, so that's 1 kilogram. 2 kilograms is going to be $18. So straight away we can say, okay, well, it's not going to be either of the 100 or the 500 grams. It's going to either be the 2,000 or the 1,200. Maybe with this 1,200, if we divide it by 6, we divide this side by 6, we're going to get $1 is going to be 200 grams. So 2,000 equals this, or that equals $6. So 200 grams is going to be $1. How did we do that? We divided everything by 6. So if we divide this by 6, we get 200 grams. If we divide $6 by 6, we get $1. Now it should be fairly easy to say, okay, well, we want to go from 200 grams to 2,000 grams. What do we have to do? We have to times this by 10. So we times the other side by 10. Whatever we do to one side, we must do the other. So we get that 2,000 grams is $10. So obviously this one is going to be the cheapest. That's one way of doing it, just looking at it, not so much mathematically, but just thinking about it. If we want to do one of these questions mathematically, because it may not come out so nicely, we can look at it in terms of what we call the unitary method. So what we're going to do is take them all down to 100 grams, because we've got 100 grams here. So instead of 500 grams, we're going to divide by 5, and we get 100 equals 88 cents. How do we get that? If we divide this side by 5, we divide the other side by 5. So straight away, this one's out. It's not going to be this, because the 500 grams is only 88 cents per 100 grams. We could do the same here. We want to go from 1,200 grams equals 6 down to 100 grams. So what are we going to do here? We're going to divide by 12. So what we'll do, we divide both sides by 12. When we divide this side by 12, we get to 100. When we divide this side by 12, we get to 0.5, which is better than this and better than this. The last one here, the 2,000 grams, what did we do to get to 100 here? We divided by 20, so we have to divide the other side by 20. And what we get is 0.625, or 62.5 cents, 90 cents, 50 cents, 88 cents. So there's two ways to do that question. One's got a little bit more mathematics and setting it out, and this way works for everything. You take everything back to, you pick a number, take it all back. In this case, because if we go back here, they were all nice multiples of 100 here. So I picked 100. Again, we have to get them back into the same. We couldn't use kilograms and grams. We had to get them all back in there. So that's called the unitary method.